reading this, everyone. It says, the formula 1 over F is equal to 1 over P plus 1 over Q is used in telescopes and camera construction, where F is the focal length of the lens. In general, the larger the F, the more power the telescope has. The variable P is the distance from the object we wish to see and the lens. The variable Q is the distance from the lens to the point of focus, such as the film of your eye. See figure below. Now, even to me, when I was reading that, I zoned out and a big jumbled mess. It doesn't matter, though. They gave us a formula. They told us what all the variables stand for. It's a plug-and-chug problem. So I don't care what any of this actually means. I'm not an eye doctor. So I say, I was given a formula. What did F stand for? Focal length. I write myself a little note. Okay, moving on. Then I say that P stood for what? Distance of the object. Then I say moving on. Then Q was the distance of what? The lens. Okay, cool. Moving on. Now look, it says, solve the formula for Q. Everybody, solve the formula for Q. I'm going to do this differently because it's just thrown everybody for a loop the way I was been solving it. Every hour, everyone's been like, now what? So let's just do it how we would do it normally. How do we solve equations? Get a what? Common denominator. So you'd say I'm going to multiply by a Q and a P, right? Q and P. This one would need a Q and F, a Q and an F. This one would need a F and P, F and P. Okay, that does not sound like I'm saying very good things. Okay, so moving on. Okay, QP. So now, guys, can't we ignore the denominator now? So what do I have? QP times 1 is QP. Then I have equals. Then I have QF. Then I have a plus FP. Now, we're trying to get Q alone. Isn't there 2 Qs? Well, if that happens, if you can remember from Sec 3, anytime we're solving, we have 2 of the variable, you need to get all of that on one side and everything else on the other side. So I'm going to bring QF over, subtract QF, subtract QF. So now I have this. QP minus QF equals FP, right? Now, can't I factor out a Q since we're trying to get there to be only one Q? Well, it's in both terms, so I'm going to pull out a Q. So then left would be divide by Q, left would be P minus F. That's equal to FP. Last step to get Q alone. Divide by P minus F. Okay, awesome. We've solved for, there's our formula. Q is equal to FP over P minus F, done. Now it says, suppose the camera has a focal length of 100 millimeters and the camera is focusing on an object 500 meters away. What is Q? So it's just a plug and chug problem. So what would I plug in? So Q, don't go anymore. I gotta uninstall this software and then reinstall it. Something. I know I say that every time, but every time I forget to do it. But then, how do I forget? Because this is miserable. Do you guys know what I'm talking about? Yeah. Okay. You don't? So you think I'm just saying like random stuff? No, yeah. Jumbling up here? Like okay. Slow. You don't pay attention then. Okay. Just kidding. I'm just kidding. No, when I click, it takes forever and then it's delayed and then, yeah. So Q is equal to, so F was focal length. What's our focal length?
100.
100, and then our P was 500, wasn't it?
Yeah.
And then divided by, and then it was 500 minus 100. So when you type that into your calculator, you get Q is equal to what? So remember, we're all typing it in so we're quicker. Q is?
Isn't it 125?
125, yes. So that wasn't hard, right? Just because there was words. It was a kind of a plug and chug problem for the most part. If you're ever given a big random formula, it's just a plug and chug problem 90% of the time. Okay. Next one. Okay, here is the thing, guys. Think about what unit we're in. We're in fractions. Every story problem is going to involve fractions of some sort. That's why we're doing it in this unit. These story problems in this unit will be fractions. So just a reminder from Sec 2, we do have to remember something. If we have similar figures, similar figure means that they're the same figure, just different sizes. They're the exact same figure, just different sizes. Now, corresponding means it sits in the same spot. So A corresponds to D, B corresponds to E, and C corresponds to F. Do you guys see what I mean by that? Corresponds, sits in the same spot. So what we can do, if you can remember back to Sec 2, is we can set up ratios of corresponding sides. Now, ratio means division. So we can divide corresponding sides. So it would be true to say A over D will be equal to B over E. And that will be equal to C over F. Now, here's one thing you just have to remember. You have to stay consistent. Did you see how I went from big to small? I got to stay consistent. So I couldn't go A over D is equal to E over B. That would be switching it. You got to stay consistent. Big to small, big to small. Okay, so what would my corresponding ratios be here? A over F is equal to B over G, right? Is equal to C over H, and so on. Okay, so let's read this. This is literally the easiest problem on your test. If you get one like this, you should be jumping for joy. It says, suppose you are standing next to a tall building and wish to know the building's height. You say, okay, I don't know the building's height apparently, so I'll call that building's height X. A light post that is 20 feet tall, so here's a light post. It's 20 feet tall, casts a shadow that is 12 feet long. So wouldn't that look like that? There's a shadow. And then it says, the shadow from the building is measured to be 660. How tall is the building? Well, isn't those similar figures? Yeah, those are similar figures. Set up a ratio of corresponding sides. So X corresponds to 20. And that will be equal to 660 over 12. So then, couldn't I just algebraically times 20 up here? What one does divide by 20? Times by 20. So I'm going to times both sides by 20. And now X is alone. So grab your calculator. Somebody should be typing in 660 times 20 divided by 12. What is it? 1,100. Thank you. Awesome. That would make sense. There could be a building of that height. So do you see how easy that problem was? And it wasn't even hard to set it up. We're drawing a picture. There's going to be a lot of corresponding ratios. What was that? Yeah, it's delayed. So it says, according to the National Vital Statistics Report dated in December 17th, 2003, the birth rate for unmarried women 15 to 44 years of age was 44 live births per 1,000 people. There's a lot of unnecessary information in there. What's going to be important? 44 births and 1,000 population probably. So it says, in the United States in 2002. In 2002, there were 1,366,000 births to unmarried women. Determine the population. So what really matters? Birth and population, right? Birth and population. So let's see what we have here. There were 44 births per what? 1,000 population. Okay, now what else were we told? There were 1,366 births. So shouldn't I write that under births? 1,366,000 births. And then it says how many population. So where would my X go? There. And isn't it just ratio of corresponding? Wouldn't births correspond to births? Population correspond to population. So let's put X on top. So I'd say X over 1,000 is equal to, I gotta stay consistent, X over 1,000 is equal to this over this. So solve for X, what would we do? Times up by 1,000, ready, go, do that. And then divide it by 44. So we get 4. Wasn't that dang easy? Yes, it was. Okay, yeah. Okay, awesome. Next thing. Okay, this one you'll want to write down. Okay, this is always how we're going to solve these type of story problems. These ones are a little different. We're going to set them up. But once you see this problem, any problem that is similar to this, you set it up the same way. So yeah, it would take some studying, like writing some notes right now and then studying it before the test. Yeah. It's actually really easy. Once you see one of them, they all work out the same way. It says, it is Saturday and Kevin needs to cut and edge the grass. At 9 o'clock a.m., Mike asks Kevin to go golfing at 11 a.m. Typically, it takes Kevin 3 hours to cut and edge the grass. When Mike cuts and edges the grass, it takes him 4 hours. If they work together to get the job done quicker, will they be able to finish in time to go golfing? Well, let's kind of see how much time do they even have to, how much time do they have to...
2 hours.
Yeah, they have 2 hours and then it's too late after that. They have 2 hours before they want to go golfing. Now think about it, write it out. So we're talking hours here. So let's kind of put things in terms of 1 hour. So everyone, we're going to let T represent the time in 1 hour. So T, we're going to let represent the time in hours. Okay, so now think about it, guys. Mike, oh shoot, well, I'm going to skip, okay, Mike and Kevin. If Kevin does the job by himself, how many hours will it take him? 3 hours. So think about it. In just 1 hour, won't he only be a third of the way done with the job? In 1 hour. If it takes him 3 full hours to finish, only a third of the way. Okay, now Mike, he gets it done in 4. So in 1 hour, won't he be a fourth of the way done? So now, 1 over T is the time of the job. So 1 over the T, we don't know the time of the job it would be, right? So if they work together. So if they work together, there'd be a fourth plus 1/3 will be equal to 1 over, we don't know the time. And then just get a common denominator. Yeah. So in 1 hour, we don't know how much time it's going to take them together. That's why I just put T. So you'd say, I'm going to multiply by 3T, 3T. I'm going to multiply by 4T, 4T. I'm getting a common denominator. So wouldn't I need a 12 and a 12? So now you'd say, when solving, I can just use the numerator. So look, 3T times 1 is 3T, everyone. We have a plus sign. We have 4T times 1, which is 4T. That's equal to 1 times 12 is 12. So isn't that 7 T's equals 12? So solve for T. Divide by 7. So our time is equal to 12 divided by 7 is 1.7. It took them 1.7 hours, everyone. So they needed 2 hours, so we're all good here. 1.7 hours. Now we could convert to minutes if we wanted. 0.7 means 70%, right? So it's 42 minutes. So we could go that far. I don't care if you stop there, but just so people are aware, that is just 1 hour and 42 minutes. They took 60 minutes and times it by 0.7, because that's 70% of 60 minutes. That's 42 minutes. Because they... Yes, you are the only one. Okay, just kidding. Juan and Maria. Okay, so let's see if we can set this one up quicker. But like I said, once you've seen one of them, they all work the same way. If you're talking how quick can you get jobs done together, you set them up the same way every time. So let's read it. Juan and Maria have a pool in a backyard. If they use their hose alone, it will take them 30 hours to fill the pool. They have a friend who has the same pool, but their hose can fill the pool in 24 hours. If they work together, how long will it take for Juan and Maria to go swimming? How would we set this up? So how would we set it up?
What if we did it in like... We have to use like a variable like T, like put 30T and 50.
You can use the smallest one, right? Least common denominator. So because this one's not a very hard one, I'm not gonna worry about it. I'll just do it because it'll actually be pretty straightforward. But no, you can do the least common denominator, right? As long as the denominator's the same, you can ignore it. So he's saying, do we have to multiply by 30 and 24? No, because maybe they could both be 60, or you know. But I'm not gonna worry that much about this one just because it's so easy. Meaning 24T, 24T, 30T, 30T, and then this will be 30 times 24, 30 times 24. So then look, we would just ignore the denominator now. So now we have 24 T's plus 30 T's, so that's 54 T's is equal to 30 times 24 is that 720. So then divide by 54. Yep, so our time is 13.3 hours. So they're going to go swimming if they put the hoses together much quicker. Pretty straightforward. As long as you wouldn't know how to do that without me going over it. That's why you have to kind of study that one. Okay, let's do one more where it's actually subtraction. So it says, suppose that the kitchen sink can be filled in 5 minutes. If the sink is full, it takes 8 minutes to drain the sink when the drain is left partially open. If the sink's drain is accidentally left partially open, how long will it take to fill the sink? Now, aren't these things happening at the same time now? The first time we were filling up the sink, right? The next time we were completely by itself draining it, correct? Now we're doing it together, right? Now, at the same time it's draining, it's getting filled, but they're at different rates. So this one's going to be a subtraction problem because it's going out as this one's going in. Does that make sense? Water's pouring out. So we'd say 1/5 minus 1/8 will equal 1 over t. And then we would just solve it the same way. Because they're not both going in. They're both going out. One's going out, one's going in. So one's positive, one's negative. Okay. I don't need to keep going with that, right? We get the picture of solving. Okay, writing down distance, rate, and time problems. So these at this point should honestly feel easy for us, and they really are all going to be pretty straightforward like this one, you'll see. So it says, a plane flies 990 miles west into the wind and makes a return trip following the same flight plan. The effect of the wind on the plane is 20 miles an hour. The round trip together totals 10 hours. What is the speed of the plane in still air? Does everybody see how this question in the wording has distance, it has rate and time all involved? So you'd have to know, you'd say, okay, this is a distance, so writing this down in your notes, equals rate times time. Now, we know the total time it takes for the total trip, the total time is 10 hours. Good to know. That's in the total time. So let's focus on just the trip there. So let's talk about, here's my plane, and it's flying this way. So what's our distance? Definitely a plane. What's our distance? 990. Our rate is, we don't know how fast. Think about it, guys. Here's my plane. It's flying, right? And the wind is pushing against us. So think about it. If I'm going in my engine pushing at 50 miles an hour, but the wind is pushing against my car at 20, I'm only going 30, but my engine's still pushing at a 50. Does that make sense, everyone? So we'd say we don't know the rate, but we know it's the rate minus the push against the plane of the wind. So minus 20. Now we don't know the time it took to get there. We just know the total time, so we have no idea, so we'll say t. Now let's talk about the flight back this way. So what's our distance? 990. Now the airplane has the wind pushing us. So if our engine's pushing at 50 and it's pushing us at 20, we're going to be going 70 miles an hour. So our rate will be r plus 20. Some rate plus 20, and then we don't know the time it took to get on the way back. So we do know the total time. So don't we need to do time it took on the way there plus the time on the way it took to get back will equal total time? So what was the time it took to get there? Well, look, solve for t. So 900 divided by r minus 20. Wouldn't that get t alone? So you'd say the time it took to get there was 990 over r minus 20. Then a plus sign. What was the time it took to get back?
990 divided by
Good. 990 divided by r plus 20. And then it took, in the end, a total of 10 hours. So now you'd say, okay, to solve an equation, I need to get a least common denominator. Anthony, do you see what we're talking about? Oh, because you were sleeping. I didn't even see you sleeping. Do you see the delayed response? I click and then 10 minutes later. See, and then it... Yeah, I just was showing you. Okay, so what's my denominator here? 1. So my least common denominator, wouldn't it be r minus 20, r plus 20? Yeah. So this one needs an r minus 20.
plus.
Oh yeah, it does. R plus 20.
That one needs an
This one needs an r minus 20.
and then that one needs both.
And that one needs both of them. So r minus 20, r plus 20. Then can't I ignore denominator?
Yeah.
Okay, so just looking at the numerator here, so we distribute 990 times r is 990 r's. 990 times 20 is plus 1980. Then we have a plus sign. What is it?
19,800.
Oh, my bad. 19,800. And then 990 times r is plus 990r. And then 990 times that would be minus 19,800. Do you agree? And that's equal to 10 times all that stuff. Remember when multiplying 3 things? Multiply 2 together and then multiplying the third. So I'm going to have 10 times parentheses. R times r is r squared. Then we have a plus 20r minus 20r. So those cancel out in this one. Then we have minus 400. So now combine like terms on this side. 990R plus 990R. 1980Rs. Didn't these cancel out?
Yeah.
And then that's equal to 10R squared minus 4,000. I distributed 10 in. You'd say, I solve quadratics by getting it set equal to 0. So I subtract this over. Now we have a quadratic, but the nice thing is we're going to end up being able to quick factor. So we have a 10R squared minus 1980R minus 4,000. And then right now I'd have to long factor, but I'm going to pull out a 10. Then left is R squared minus 198R minus 400. So you'd say I can quick factor what multiplies to be negative 400 and adds up to be negative 198. That's going to be 2 times 200, negative 200, right? So we have this 10, we have an R plus 2 and an R, that's an R. R minus 200. So what are my two solutions? R equals negative 2 and R equals 200. Could the rate of a plane be a negative mile an hour? So cross that one out. The rate of the plane is 200 miles an hour.
And the 10 doesn't matter because we're solving.
Right.
Okay.
Awesome. Okay, so let's do one more distance, rate, and time problem. We'll just set it up. We don't have to go through the whole thing if you don't want. Okay, so but once again, guys, you just set up distance, rate, and time for both trips. So let's read this one. It'll go much quicker, I bet. Yeah. Okay, a canoe travels on a river whose current is running at 2 miles an hour. After traveling 12 miles upstream, the canoe turns around and makes a 12-mile trip back downstream. The trip up and back takes a total of 8 hours. What is the speed of the canoe in still water? So you'd say distance equals rate times time. Okay, what's the distance on the travel there? 12. Our rate is? Upstream.
2.
R, we don't know the rate, right? R minus 2, because upstream would be water pushing against us, and then we don't know the time specifically that it took to get there. Then our distance on the way back is 12. Our rate is now going to be R plus 2 pushing us, and we don't know our time. So the time for this one, wouldn't that be 12 over R plus minus 2? The time for this one would be 12 over R plus 2. And now the total time would be taking those and adding them. And then it equals 8. So you'd get a common denominator, solve. It will be a quadratic that factors. You will not have to use a quadratic formula. All good? Okay. Sweet. We're almost done. Okay, now this is the part that was new to me, but you have to know it. It was new learning. I haven't learned it in a long time, or I've never learned it, or whatever. I was sleeping like some people during this lesson in high school. I don't know what it is. So we're learning, you got to start writing this down. So this is just some formulas that basically, here, let me explain it like this, because it was I was like making it harder than it was. These are formulas that we write, and it's all based on how they word it. So it says right here, suppose X and Y represent two quantities. X and Y just means two amounts. And if we have this formula, it's saying that Y varies inversely with X. So basically, they're not going to give you that formula. They're going to say Y varies inversely with X, and you have to know to set it up this way. So everybody look. Y varies inversely. The word inversely is divide, and then with X. Now K is just some constant that we always solve for in a second. We're going to be given enough information with these problems to always solve for K first. So K is always going to be on top. You'll just remember that. So, this is just how it reads. Y varies inversely, that means divide with X. So look at this next, look how we would write it. It says the weight W that can be safely supported by a 2-inch by 4-inch piece of lumber varies inversely with L. So you'd say our weight equals, it varies inversely, so that'd be divide, with L. And then K is just always there. We just have to know that K is some number, some constant. So now let's read part A. It says, experiments indicate, so this is talking about people that can walk across without the board snapping. Yeah, so it says, experiments indicate that a 12-foot pine, 2x4, can support 400 pounds. Find a function that relates the maximum weight to the length L for any pine. That's a 2x4. So the 2x4 doesn't matter. So what are we plugging in? How much weight? 400. That's equal to, K is what we're going to be solving for every time in our first step for these. Our length is 12, isn't it? So now solve for K, so you times by 12. So K is 4,800. So now you'd go back and say, okay, so my formula is actually W is equal to 4,800 divided by L. I'm telling you, every time with these type of problems, the first sentence or the first step, they will give you enough information to solve for K first. Now it says, determine the max weight that a 15-foot pine can sustain. So then we just plug in 15 now there. So weight is equal to 4,800 divided by our length is 15. So now type that in, and our weight is 320 pounds. It's pretty easy as long as you know what you're setting up. It's really just knowing how to set it up, and then it's a plug and chug problem. Okay, so that was how varying inversely works. It's divide. So now we have to know the word also varying jointly. So varying inversely, we just saw that. So look, this is saying y varies inversely with z. Do you see that? This is y varies inversely with z and x. Now jointly just means multiplication. So this reads y varies jointly because times means jointly. So jointly with z and x. So this would say y varies, there wasn't a jointly because there's nothing multiplied to k. K is always there, notice. So this says y varies jointly with x and y because they're times. So they can do multiple things in one. This would read y varies jointly with x and y, but inversely with z. So jointly means multiply it to k. So yeah, I wrote a little note for you. Jointly means you multiply it to k. Inversely means you will take k and divide it. Divide by it. So I could literally write any problem. Like for example, if I went like this, y is equal to k, and then I said x, y, z divided by pq, what would that read? Y varies jointly with x, y, z, but inversely with pq. Yeah. Awesome. Okay, so now we'll just use that. So you just have to remember, jointly means multiply it to k, inversely means you take k and divide by it. Okay, so let's read this one. It says, the force F of the wind on a flat surface positioned at a right angle to the direction of the wind varies jointly with the area of the surface and the square of the speed v of the wind. So you'd say, okay, force F is equal to, k is always there, and then was it jointly or inversely? Jointly, so you'd say it's times by and what variables? A and, yeah, the square of v. This one has tricked me until somebody pointed out to me that in physics last hour, they're like it's v, when it said square of the speed, it meant v squared. I'm like, oh yeah, that makes sense, I guess. Yeah. So now it says right here, in the first sentence, once again, your first step always will be enough information to solve for k first. So it says, the wind of a 30-mile-an-hour blowing on a window measuring 4 by 5 feet. So we have a 4 by 5 foot window here. And then the wind is blowing on it at 30 miles an hour. Has a force of 150 pounds. So let's plug in what we know. Our force is 150 equal to, we don't know k. Our area of this window is 20. Good. And our v, which usually stands for velocity or speed, is 30 squared. So everyone, take your calculator, and you would take and multiply whatever that is. So you have 150 is equal to k times whatever that is. So then you would divide by 18,000. We're going to get a decimal for k. So k is equal to what? .00278-ish. Does it go on past that, or is that it?
It's 27777.
Okay, cool. So we'll just go there. So you'd say, okay, so our formula is this. F is equal to 0.00278 area and then velocity squared. So now your next sentence will literally just give you, it's just a plug and chug problem. It says, what's the force on a window that's measuring 2 by 6 that's caused by a hurricane force wind of 100 miles an hour? So force is equal to 0.00278. Our area for this one is?
Yeah, 0.008.
Okay.
I don't mean,
Yeah, it does.
Yeah, because it's how to be closer.
If it was just a rounding difference, I would have probably said no, but it was a, okay. So you got 0.008. Okay, so then this would be 0.008. What was our area? 12. And our velocity or speed on this one was 100 squared. So now you would type that in, and what's the force it can withhold without breaking? These are all physics people problems. Where the mathematicians teach physics people how to do math, and then the physics people are the really smart people because they go apply it. Yeah? 960, anyone else? Well, at least you're helping, right? Okay. 960. I'd rather have someone helping and get it wrong than sitting there twiddling their thumbs. Okay, awesome. Okay, this is my last example here. This is the last one. So it says the force required to keep a car traveling 30 meters per second on a circular road with a radius of 50 meters is a force of 21,600 newtons. Determine the force required to keep the same car on a circular road if it is traveling 40 meters per second on a road whose radius is 30 meters. Use the formula below. Remember, so it already gives us the formula. So here's a varying jointly with V, the square of V, right? And inversely with R. So let's plug in what we know. Once again, the first sentence will always give you information to solve for K. What was our force? 21,600 newtons, right? And that's equal to, we don't know what K is, our velocity or speed was 30 meters per second. So 30 squared, and what's the radius? 50, so calculator people. 21,600 times it by 50. And then divide it by 900, because 30 squared is 900. Is that the final answer? Yes. So now you would go plug that in and say force is equal to 1,200. Now let's read the next sentence. What's our velocity? Determine the force to keep the car on a circular road if it is traveling at 40 meters per second. So 40 squared if the radius of the road is 30. So then you would just calculate it. Do you see how it really is just a plug and chug problem though? Yeah, we solve for K and then we can plug it in.
How can we tell if it's inverse?
So once they'll either give you the formula already, or they'll inward say the force varies jointly with the square of the velocity and inversely with the radius, or they'll just give you the formula. Great questions. Okay, awesome. So I didn't finish calculating that one because I think you get the picture. So right now, go practice those ones, and we're only doing problems. We're only doing problems. Oh wait. Cross out. There's ones I need you to cross out. I'll tell you which one. Don't be your host, but it's not mine. That's 6 months more. So you're gonna cross out 23 and 24 because it says varying directly, which is easy, but we didn't learn that, and I'm not gonna test you on it. So.